let's say a liter of diesel is $1. Green hydrogen would have made the diesel for $5. In the past, if you would have come in at 250 or $2, you would have been 50% better and someone probably would have gotten excited. Now the message is very simple. $1 isn't even good enough. You have to be 90 cents or 80 cents. We've just recognized if you really want to scale up and have an impact, you have to be better than the existing system.
Hey, I'm your host, Justin Rice, the founder of Climate Tech Canada. As we build out the energy transition, there are parts of the economy that just can't run on a battery, at least not yet. Aviation, shipping, heavy industry, sectors that move people, goods, and materials around the world and that will need liquid fuels for decades to come. We know how to make low carbon versions of those fuels, but they've largely failed to reach scale for one reason: price. Buyers like airlines, fuel distributors, and chemical companies can't absorb a green premium when fuel already makes up a big part of their operating costs, as much as 30% in some cases. Green hydrogen was supposed to be a big part of the answer, but it's largely struggled to close the price gap and scale up, with several high-profile project cancellations and plant closures over the past year or so. Jochem Kamstra thinks that there's actually a better route. He's the founder of Secant Fuels, a Canadian startup that's turning CO2 into syngas, the building block for low-carbon fuels like methanol and sustainable aviation fuel. Secant Fuels uses heat instead of electricity to create its fuels, allowing them to better compete with fossil fuels on price, and a distributed production model that integrates with industry, allowing chemical companies to turn their waste CO2 streams into the valuable inputs that they use in their operations. We'll unpack why Secant's carbon-to-fuels technology could actually hit price parity with fossil fuels, the CO2 feedstock challenge that most people don't expect in this industry, and the impact of regulatory tailwinds like EU SAF mandates and Canada's low-carbon fuel standards. We'll also zoom out and talk about the low-carbon fuel space more broadly. Many investors have some scar tissue from Cleantech 1.0, the biofuels boom, and now green hydrogen. We'll talk about how that's shaping investor perspectives and what it actually takes to close deals in a commodity-driven market. And now, my conversation with Jochem. Jochem, welcome to the show. Thanks for joining us. Great to have you here.
Thank you very much. Pleasure being here. Looking forward to it.
Me too. So I'm really looking forward to this conversation. I would love to maybe just start off a little bit on the origins of the company and Secant Fuels. Maybe just tell us a little bit about where the company came from and the problem that you're solving.
Sounds good. So the origin story is that the technology was actually founded by a university in Canada. To be precise, it's Sherbrooke University in Sherbrooke, Quebec. And I think as often goes with technology development, not everything was planned from day one. So it started off that the university has an applied research biomass lab, and they were looking at methane reform, so feeding methane into a reactor and see what comes out of it. That idea led into what happens if we just feed CO2 into the reactor, and they were producing synthetic gas, and syngas is a mixture of hydrogen and carbon monoxide. That led to further development. The lab won a grant with Enercan in their Clean Fuels Challenge, and that really led to them being able to further develop the technology. And after about 3 years, they basically hit the crossroads. They had to file for patents. And the two professors, Jean-Michel and Bruna, whose name is on the patent, had a decision to make to say, we don't take the next step. This is just going to become an experiment in the lab and it's not growing into something else. And they really saw the value and the impact that the technology can bring. So they reached out. There's an organization called Hard Climate, which is a venture studio out of Montreal. And Hard Climate's focus and specialty is really to get technologies out of a university lab and turn it into commercial startup. So long story short, us two parties came together. At the time I was at Hard Climate, and we really had a very good mix of the right people, the right skill sets, the right attitudes. We mixed really well, and we created Secant Fuel 2 years ago.
The Hard Climate model is super interesting, and I feel like the story you tell there about the researchers kind of coming to that inflection point is a common one, and getting over that jump into commercialization.
Yeah, I think it's a very unique challenge, right? Like if you're a professor, some are very interested in creating a startup and are very successful, and some are like this is not my focus. I don't have the time or the skills or the network to do it,
Yeah.
or the cash to do it, because you need to spend money to be commercially successful.
Yeah, for sure. And so, tell me a little bit about the technology as it is, and kind of the problem that you're solving.
So I already mentioned that we convert CO2 into synthetic gas, and I typically start there. Some people know exactly what syngas is, but a lot of us might not have heard of it.
Yeah.
So syngas is a mixture of hydrogen and carbon monoxide. It is not an end product. Syngas is typically converted into something else, and I often compare it with hydrogen. Hydrogen is typically not an end product either. It gets used. It's the energy carrier that gets converted into something else.
Okay.
But syngas is actually really an essential feedstock for a lot of things. So if you look at how is the world's ammonia produced today, for example, for fertilizer, it's predominantly made from syngas. How do we make all our methanol today? It's predominantly made from syngas. Even if you look at 95% of the world's hydrogen produced today, it's called gray hydrogen because it's made from natural gas. The first step is to turn natural gas into syngas and then turn it into hydrogen. So it's a
Mm,
very essential element in the
yeah.
world of decarbonization. The value of syngas is that you can convert it into methanol, which is a chemical, but it's also a fuel that the marine industry is looking for. You can turn it into renewable diesel. I think we all know, obviously, what we use diesel for. And you can turn it into sustainable aviation fuel for the aviation industry. So it's a very useful product, intermediate product that allows you to decarbonize a lot of downstream sectors.
Got it. Okay. So you're kind of taking, captured CO2 and converting it into this like syngas building block. And then that is ultimately converted into like a useful fuel that you would use in like sustainable aviation fuel or things like that. Is that right?
That is correct. And how our technology works at its core is that we use what we refer to as a thermal catalytic reactor. That's a
Mm,
fancy word, but it really means that we run at 700 degrees Celsius, and that's the conversion happens catalytically. So if you look at how do we make these green methanols or SAFs today, it's often made you start with green hydrogen production and CO2, and you blend the two together. The challenge if you start with green hydrogen remains the cost of hydrogen, and that puts
right.
the green premium from 5 to 9 times that of its fossil fuel cousin. And because we don't use electricity to split molecules, we use a catalyst and we use heat.
Hmm.
It's a more efficient process, and from a capital perspective, it is significantly cheaper, and that really allows us to produce these fuels at the same price point as fossil fuels. That's the holy grail. If you can do that, then you're radically changing the world. And most customers are, I'd say it's a mix, unwilling or just unable to really pay for a green premium. If I
Right.
often use the airlines, if 30% of their cost is the cost of fuels, it's actually very difficult for them to pay a premium. So being able to get very close to what they're paid for their fuel today is very important.
Absolutely, yeah. And it seems like the cost has been it seems like the key barrier for adopting a lot of these cleaner, low carbon fuels. They're not able to compete on cost. And so is the sort of the advantage that you're bringing to the table is this, kind of using heat as the input instead of electricity. And is that kind of the differentiator that lets you kind of deliver this at a lower cost?
I think the differentiator is in two aspects. One of them is, yes, that we use heat and not the electricity. The other part is that we have an iron-based catalyst. We operate it in a proprietary way, but the iron, it's not purely a catalyst. It actually participates in the reaction. So it strips the oxygen out of the CO2 and water. So it oxidizes in the process. That's how we convert the CO2 and water into syngas. And then we have a proprietary method where we regenerate the iron. So it's really the two components combined that allow us to have a very efficient conversion methodology.
No, this is really exciting, and I think it's such a huge market that seems like it's also been like kind of clamoring for a solution that can properly compete on cost. We've heard like sustainable aviation fuel. There's all these like goals for increasing the adoption, but supply is having a hard time. Buyers, the price remains an obstacle. So it's a really exciting opportunity here. The last time we talked, you mentioned that actually those CO2 feedstocks at the right purity and all that, like actually finding those was one of the biggest challenges early on. And from where I'm sitting, I'm like,
Yep.
it seems like CO2 is everywhere. It's like a big
Yep.
problem. We need to like
Yep.
get rid of it. Yeah, maybe just like walk us through
Yep.
like why is finding this waste carbon so much harder than we might think?
I think that was one thing we certainly underestimated. When
Mm,
I walked into Secant Fuel on day one, I never thought that CO2 would be our challenge. I thought the same as you. I'm like, we have a massive CO2 issue, and it should be easy to get. I think the challenge is for most of us that you need CO2 at a certain purity. So for us, we need it at 90% or greater purity. It doesn't exist at that purity, then you need to do a primary step first, and that could be a carbon capture unit or a membrane technology that upgrades it from maybe 20% to 90%. And the problem there is just you add complexity and cost to the project. So as a startup, what we need to prove and scale is our own technology. We're not in the market to scale up and prove carbon capture. Carbon capture
totally. Yeah.
is known, but if the customer doesn't have a carbon capture unit on site yet, and they simply have, flue gas emissions that are 2 or 8%, then they do have a CO2 emission problem. They do want to decarbonize, but someone has to take the carbon capture step. That is, as a project developer, you would likely do everything. But as a startup where you're very focused on, I have
Yeah.
limited time and resources, and I really need to do what I need to do, and that's scaling up our own tech. In an ideal world, we work with someone who either naturally has higher concentration CO2 coming off their process. That does exist. And it actually exists more than most people realize. But of course, it is more limited than the overall amount of CO2 that we emit.
I'd love to maybe talk about how you're thinking about some of those different markets.
Yep.
So you talked a little bit about, syngas is used in like chemicals, sustainable aviation fuel. How do these carbon derived fuels compete with some of the other low carbon options? Are they fundamentally different market opportunities you're pursuing, or this is something you think you could kind of plug into various different markets?
I think the short answer is you can plug it into various different markets. So we, as a technology provider, that's how we position ourselves, not as a project developer, but really as a technology provider. We're
Right.
kind of agnostic of the end product. As I said before, syngas is really the feedstock into the secondary pathways. And those secondary pathways are all well known and well developed. Whether you use a Fischer-Tropsch technology or a methanol synthesis technology, those technologies have existed for 100 plus years. So if someone wants to go to diesel, then we would simply take our process, we would purchase a commercially available Fischer-Tropsch process and convert the syngas into diesel. So in that regard, we're not tied to one specific market. There definitely are markets where we see more interest versus other markets. So clearly, from a market driver perspective, we are
Mhm.
focused on the markets that are the first movers and are putting more money and effort into finding an alternative to what they consume today.
Yeah, I'd love to maybe just double click on that and go a little bit deeper into some of the market signals that you're seeing. Like, what separates some of those markets that are, acting as first movers versus, ones that maybe are going to be the followers or kind of a later adoption?
I always hate to say this, but I do think there's a lot of truth to that. It ends up that the regulatory frameworks often
Mm,
force a change. I always say no pain, no gain. If you, even though global warming is a really large issue, if you're not very specific with certain market segment or a customer to say you have to change your behavior today, it's hard for them to do because they're very profit focused and they have their shareholders and investors that want them to be profitable. So it's actually very difficult for a company to say, let me take 2% of my profit and put it into a decarbonization project. So that's clearly where regulation comes into place. What we are seeing is that Europe has their SAF mandate, so it's 2% by 2030. Asia is very focused on this, and specifically in Asia, for example, Japan. So Japan has really recognized in the last 2 years that synthetic fuels or low carbon fuels will play a very key part in their decarbonization pathway. We see a lot of activity coming out of Australia, for example, both from the airlines perspective, but also from the government perspective. But even in Canada, with the clean fuel standards and the recent announcement of the clean fuel funds, there's really money starting to flow into this. So it's long story short, a lot of it right now is on liquid fuels.
Hmm.
I'd probably say sustainable aviation fuel and diesel are probably the two main drivers. The secondary market where we get a lot of interest from is the chemicals market.
Okay, yeah.
The reason there is they turn it into a product that consumers purchase, and consumers are conscientious of climate change, obviously, and are interested in buying green products. Slightly slower followers because the risk for adoption for them is greater.
Hmm.
And the chemicals market right now is globally is not the most profitable market, so they have a bit less money to spend.
Right. Okay. That's really interesting. One of the challenging things about this sector and a couple of other areas in climate is like, this is kind of like a commodity area where a lot of this kind of comes down to like competing on price, but also like volume, or as you mentioned, the risk to integrate into these like massive processes. I'd love to just get maybe your thoughts on like entering into a space like that. What have been some of your, early takeaways or lessons from the space, and how do you think about entering like a commodity kind of driven market?
It's very true, and it's a very valid question. It's really a double-edged sword. That on the one hand, because you play in a commodity-driven market, you play in a really big marketplace. So if you crack the
Mm,
nut, then the sky's the limit. So you really have, right, the liquid fuels market. What is it, 2-3 trillion a year?
right. The
So
upside is like massive.
the upside is massive,
Yeah.
but it is 100% the challenge, right? That if you talk to people, you only really have an impact if you do something at larger scale. You don't want to make 5 liters of diesel, you want to make 5 million or billion liters of diesel.
Yeah.
The way we have approached it is that we've really taken a hybrid approach. We recognize that over time we need to scale up to, let's just say, refinery scale sizes. But we also recognize that it takes a long time, it's risky, and it's expensive. From an investor perspective, there's not a lot of appetite right now to invest into those technologies that really take 15, 20 years. So we have tapped into a market that is smaller, but where people are buying this, but because they're buying at smaller quantities, they're not producing these products themselves, they're buying it through distribution channels. And what happens then is A, that there's multiple markups in that channel, and B, the products get shipped over large distances, and transportation easily adds 30% of the cost of these products. So if you can make it locally at smaller scale for the right people, you actually have a really attractive market. And yes, for us at smaller scale means that the end product that you produce is more expensive because still scale will always matter. But because you take the middleman out and you take the transportation cost out, there's actually still profit left in those smaller markets.
That makes a lot of sense. It's interesting because I've heard various companies taking a more modular and a more distributed approach where you're kind of producing closer to the point of consumption, which to your point, helps on price. But I would imagine also helps on the carbon footprint side because you don't have to incorporate this transportation emissions of actually getting the fuel to an end customer and things like that. So there's the flue gas aspect. Have you looked at or would consider looking at other sources of CO2 like biogenic CO2 or direct air capture or kind of those other pathways?
Yes, and I often say we start with the low-hanging fruit, and for us, the
Mm,
low-hanging fruit is any process that produces close to pure CO2, and any fermentation process, like whether you're a brewery or whether you make yeast or whether you make sugar. If you process food waste to turn it into, for example, renewable natural gas, or if you take
right.
methane from a landfill, Those processes typically produce 50 till 100% pure CO2. And even if you look at like gas processing facilities, for example, Alberta, when you have sour gas processing facilities, they take the CO2 out
Hmm.
because those people don't want to move CO2 in a pipeline or compress CO2. They just want to
Right.
compress natural gas. And it's the same if you look at a liquefied natural gas processing facility. They first take the CO2 out. So there are processes already that produce pure CO2 and simply right now push it into the atmosphere because they have no solution for it. So that's the low hanging fruit because we don't need to spend any extra money. You simply have to take their existing CO2 and push it into our technology, and it's a perfect fit. And then you go down the ladder, and it's the same for a carbon capture unit. The lower the CO2 concentration that comes out of a process. So a great example is a natural gas-fired power plant. It's about 2 to 3%. It's the most expensive process to capture the CO2 in.
That's really interesting. So it strikes me that there's these sources of CO2 kind of all over the place, different volumes, different purities. It seems like a huge opportunity for Canada. And particularly thinking about like in Alberta or even in British Columbia, oil and gas production, natural gas, all that kind of stuff. I'm curious your take on, what do you think would need to change to really unlock that as, a productive feedstock? We're talking
Yeah.
about large scale carbon capture projects, sequestration. Be curious about your thoughts on like large scale, utilization.
I think there's a couple of things that need to happen. First, the people right now, anywhere in the world that are doing large scale carbon capture, tend to look at sequestration. So whether it's
Hmm.
Alberta, whether it's Northern Europe or Australia, those people are looking at sequestration. The main reason is if you capture your CO2 and you sequester it, you're getting very close to a net zero footprint, right? You've taken care of your scope 1 and 2 emissions. If you then turn it into a fuel and you burn it and then you release it again, while the overall life cycle analysis is very beneficial, you do reduce carbon intensity by about 95%. You get into the challenging conversation, who gets the carbon credit? Because the people who do
Right.
the carbon capture want to say, I've reduced my emissions to zero. And the
Mm.
people who buy the fuel are saying, I'm buying low carbon fuel. And you can't do double counting. You can
Yeah,
split
yeah.
it, but you can't both get the same credit. So regulatory frameworks there are important to just simplify that process and recognize that the overall carbon intensity reduction is significant by utilizing CO2. I think one of the other things where we are seeing more interest is actually smaller emitters. So the really large emitters that have the ability to pool their resources together, like Alberta is a great example, right? So there's about 12 or 20 million tons of CO2 emissions. It's so large that they can collectively build a pipeline. They can
Yeah.
collectively invest in sequestration, but all the steps are expensive. If you are a smaller emitter that maybe emits 100,000 tons or 500,000 tons, you will never have the capital to do those large scale projects. So you really have no path forward today. And I think that's really where utilization comes in because we can simply tell them all you have to worry about is capture your CO2. And we basically become your garbage collection, right? You put the CO2 at the waste site, I come and pick it up, and you don't have to worry about it anymore. And I think that's what really resonates with people. But clearly,
Mm.
the two things that need to happen there is carbon capture. The cost is still relatively high. There are a lot of carbon capture companies now that also recognize that same value proposition. So their technology scaling is more focused on the 100,000 ton unit. And then clearly, our technology needs to scale up till a level where we have the data to prove that we can take CO2 and
Right.
turn it into a product at a certain price point. I think if that happens, if there's a few projects that have delivered on that value proposition, I think that's where the light bulb goes off and people will move forward faster. But as with all of these, if people don't understand the risk or if the risk isn't well quantified, the easiest pathway is to wait.
Yeah, yeah. So I guess that's where also those kind of smaller scale projects that you're talking about are really helpful because you get real world data in the field deployed, and that builds a lot of confidence, I would imagine. On the website, I saw there's a point about this CO2 utilization and your process also helping drive down the cost of carbon capture projects. Could you talk a little bit about that aspect, whether that like what does that kind of mean for project
Yeah.
economics to actually deploy carbon capture?
Yeah, it drives down the costs in a couple of areas. The first one is if you don't have to transport and sequester it.
Right?
That's a
Yeah.
very simple one. Like we talked about the cost of transporting liquid fuels, but the cost of transporting gas is much higher. You don't transport gas, you compress it into a liquid, but that compression stage takes a tremendous amount of energy and is costly. So we simply take a portion away because we utilize it and we work at atmospheric pressure. So we take the CO2 in its gas form, it does not need to be compressed. We take a portion of the carbon capture unit away. I already mentioned it because we work at atmospheric pressure, they no longer have to compress it. Our process takes water, so they don't have to dry the CO2. So we actually, our process runs on heat, they produce some waste heat, etc. So there's just some synergies
Yeah, yeah.
that help. Now, that's a smaller portion. That's maybe 5 to 10%. I think the bigger one is if you don't have to move it and sequester it. And then the third one is simply the possibility of having the utilization available to you. So when we say we bring down the cost of carbon capture, it's really the notion of maybe the technology cost stays the same, or we reduce it slightly, but the overall value chain gets better, right? Because we take a waste product and turn it into a value stream. So we
Yeah.
might, if our technology is efficient enough, we might, for example, be able to offer someone 25 or $50 per ton of CO2.
Okay.
So the
So that
CO2 turns into a product that has value for the world. There's a dollar you can assign to it.
yeah, yeah, absolutely. And do you see that being a case where the customer that has carbon capture installed is actually using the end product that you're creating, like that syngas conversion is actually used in their operations, or that's sold into other customers?
Both the chemical
Mm,
industry for sure is an integrated process, which is why it's an area we're focused on, and I think why those customers respond very positively. They have
yeah,
large CO2 emissions because they burn a lot of gas for steam production and all kinds of things. And they produce syngas at site today because syngas is an essential feedstock for them to turn into hundreds of other products. So there, the value proposition is quite simple. I can take your CO2, I can take your waste heat, and I can turn it into a product that you already consume. So it is
yeah,
really, I almost call it, it's like a black box solution. You don't need any external other parties for this project to happen. You just need yourself. You have the
yeah, yeah.
feedstock and the offtake agreement all at the same site.
No, that's super interesting, and I think this kind of industrial integration and waste to value, it seems like a value proposition that gets a lot of traction with industry too. Like it just cool, we can have that black box that actually feeds our operations. But imagine that's great for their bottom line. So I was really interested in this kind of. It seemed like a bit of a chicken and an egg problem in the carbon utilization space, where you have finding the CO2 supply and inputs, a nascent market, still kind of figuring out how to procure and how much these low carbon fuels to buy. How are you thinking about kind of de-risking both sides of that equation simultaneously? You talked a little bit about it in
Yeah,
terms of like scale and things like
yeah.
that, but would love to just get your take on that situation.
I'll start by saying it's not easy.
Yeah.
It's a lot of conversations, a lot of hard work. I think part of it is you have to find simply the early adopters, the people that are interested enough in this pathway that they're willing to take the higher risk at these early projects. You also have to be, I think, smart enough to find the business case and really being able to articulate the business case. What I have found is if I show up with customers and I simply say, I can take your CO2 into this, and I don't draw the larger picture, what it really means for them, they they don't always instantly understand it. So you really have to say, hey, this is what it does for your carbon footprint. This is how it creates value. These are the products that you can sell. This is the potential extra revenue that you generate, and this is the return of investment that you get. Let's say it's 3 years or 5 years or 6 years. So you kind of have to draw that picture out, and as soon as you do that, you get this aha moment, and then there's a group of people that get genuinely excited. They're like, you know what, we really care about either decarbonization or we're really interested in the liquid fuels market, and then they're willing to take the time because the first step is to get someone interested. The second
Mm,
step is then, I always say the devil is in the details. You got to be very pragmatic and look at the details and say, what does it take to get a project off the ground? What do we need? What do you need? How do we execute it well? And then you have to move through that. But it is hard. And I think for us, that's why our first focus is on that low hanging fruit. Who are the people that already produce close to pure CO2?
right.
And even within that segment, what's the easiest ones for us to integrate in? So, for example, if you have a brewery that produces pure CO2 on paper, that sounds great. But a brewery doesn't have the right environmental permits that would allow us to make a liquid fuel.
Got it.
If
Yeah, yeah.
if you work with a facility that takes landfill gas and produces renewable natural gas out of it, now they have the CO2, but they already have the permits in place too, because this is what they do, right? So they're
Yeah.
at an industrial site, they know what to do. The brewery is in downtown Montreal or Toronto where it's hard to pull this off. So I think I sometimes feel like you're Sherlock Holmes. You have to really
Yeah,
understand
yeah.
what are people's motivators to say yes or no, and what are the three, four things that lower the barriers enough that it makes it easier for someone to say yes.
Yeah, yeah, very interesting. Okay.
Yeah.
And then I was really interested. So you mentioned on the go to market side, the impact that the regulatory frameworks can have. I'd love to hear from you. What impact do Canada's low carbon fuel standards have on carbon utilization as a pathway? We can maybe talk about like, what's working well or some of the positive signs, and then maybe like what's missing and still kind of needs to come together.
It actually feeds back into the chicken and egg question that you asked, because the
Yeah.
third ingredient that I forgot to mention is grants, right? So
Mm,
if you have a customer that's excited enough and you now get a grant that pays for half the project, things are starting to move. I think LCFs are important because they drive a behavior change, they signal a market change, and it goes back to the no pain, no gain. It's a bit early days, I think, in Canada to really see where this is going. But a great example is the recent Fuel Innovation Fund announcement. So
mm,
I had the opportunity to meet with the fund administrators last week. So the way that this fund works is that if there are fuel producers or refineries that don't meet the threshold, the carbon intensity threshold, and I think this is where Canada's really starting to get it. I really have to give a lot of credit to the federal government working with everyone to set this up right. Because in the past, we called it a carbon tax. And as soon as we call something a penalty, everyone gets up in arms and say, who are you to charge me? But this is really
yeah.
set up as an incentive program.
Mm,
And it works way better to have carrots versus sticks, I think. So if you don't meet the standards, you pay into this fund. 75% of this fund gets paid back out to the emitters. Let's call it a refinery.
okay.
If the refinery implements a project that decarbonizes it, then they get that project funded out of basically the money that they paid into that fund.
Got it. Yeah.
25% of that fund goes to new technologies like ours. So they will have an open challenge every year. And it's all about scaling up new technologies. So I think it does two things, right? A refinery has a higher motivation to implement new technologies. So not only basically are they forced to put some money aside, I almost call it a savings account. They're also now more interested to work with someone like us. And secondly, we get portion of our projects, typically up to 50%. Most of the grants in Canada are you get 50%, you have to bring 50% yourself. But having 50% of a project paid for is game changing. It really allows you to move forward a lot faster.
Yeah, yeah, absolutely. And it's so much more attractive for partners too to sign on where they know that those costs are, a portion of those costs are covered. I'm curious, I don't know if you've looked at or had looked at other jurisdictions when kind of starting the company. But I'm curious, like, what's your take on how that stacks up to say like the US or the UK when it comes to some of these like incentives to get low carbon fuels and utilization off the ground?
Yeah, I'll maybe answer it on a slightly higher level. I
Yeah.
don't know the details of each one of them, and the details can be quite finicky. But strategically, if I look to North America, what are the regions outside now, like the federal government in Canada, with this clean fuel standard, is things are moving forward. It was probably in the US, California, and New York that are still focused on this. I think, unfortunately, a lot of the rest has deprioritized its focus.
Hmm.
The two regions in Canada that were strongest were probably Quebec and British Columbia. They had the incentive program and regulations in place to really have a shift in behavior for consumers and producers and companies alike. But globally, I think what we're really starting to see is I already mentioned, I think the SAF mandate in Europe. So
Hmm.
it's 2% by 2030. What they added to it is what a lot of people don't realize is, let's say you're Air Canada flying into Europe. If you refuel, I think the threshold is 70%. If you refuel more than 70%, you have to participate in the 2% clean
Oh,
fuel
very
standard.
interesting.
So
Yeah.
you don't have to be a European airline to have to participate. It's every airline flying there that's refueling in Europe has to participate.
Right. Okay.
Right now, word on the street is that they will really struggle meeting the 2%, and it's going to increase every year. And there's a penalty that you have to pay as an airline if you don't meet it. And I mentioned like Japan, Singapore, Australia, that are really moving forward. The Australian airlines have given themselves a target, quite an aggressive target.
Okay.
They also recognized it's challenging for them to meet it, so they have put, I think, a 200 million fund in place, very similar to really help scale up technologies and to pay for project development.
Yeah, and I think Singapore just launched a fund for sustainable aviation too, or a levy on flights to kind of kickstart that market. And you had some big players jumping into that. I think Google was one of the biggest ones, but it does seem like a lot of people are really trying to crack this nut and get it off the ground. So
Yeah,
I think your point there of like Canada's regulatory framework is one, but the fact that you have this kind of participation, particularly with airlines flying around the world and participating in all these markets,
yeah,
those are forces that are going to have like knock on effects everywhere, really.
yeah. It's really I really think that the last 18 to 24 months, those market signals are it's the classic S curve, I think. Like,
Hmm.
and even though 2% might sound small, if you talk about real volumes, it's a lot of fuel.
Yeah, yeah, for sure. Yeah.
Yeah, so it's really happening. I think we know that the maritime industry, even though they voted to postpone their standards, I think most of us expected they will follow sooner than later. And
Hmm.
even in that industry, right? Like both of them, there's large players. Like in the maritime, there's Maersk. In the shipping, there's DHL. Those players are taking a lead role, and they are actively buying clean fuels. So similar
Yeah.
to the carbon credits that really like the Googles and the Microsofts of the world have taken a lead,
Hmm.
there's a group of companies in the fuel space that are really taking a lead position.
That kind of just jogged my memory. I feel like a lot of folks have some scar tissue around like clean tech 1.0 and like biofuels and that whole rush. In a similar vein, there was kind of a lot of focus on green hydrogen, and a lot of that is since struggled or didn't pan out. I would imagine that's something that kind of comes up when you're talking to potential investors. I'm curious to get your thoughts on, the investor sentiment around this space, but also like what's different today when it comes to carbon utilization and low carbon fuels.
You're 100% correct that there's scar tissue and people are skeptical. So the way it shows up in investor meetings is really twofold. A, it's just harder to convince
Get
someone to
the
make an investment. It's as simple as
Yeah.
that. And the threshold has really become that if you do your techno-economic analysis, that let's say a liter of diesel is $1.
Hmm.
In the past, So let's say green hydrogen would have made the diesel for $5. In the past, if you would have come in at 250 or $2, you would have been 50% better and someone probably would have gotten excited. Now the message is very simple. $1 isn't even good enough. You have to be 90 cents or 80 cents.
Oh,
So you have
interesting.
to really beat the existing system. And I think
Hmm.
the reason for that is that we've just recognized if you really want to scale up and have an impact, you have to be better than the existing system. And I think solar and wind have shown it, right? Like solar in most areas is now the cheapest form of electricity production.
Yeah.
That's the main reason of solar adoption. It's not because we love solar, it's the
Hmm.
cheapest form of energy. So you do really see that ask from investors or that demand to say, show me that you can either be on par or ideally beat the existing system.
It's interesting to see that, comfort with a green premium kind of fall away. And now
Yeah.
this focus on, yeah, you have to be better than the incumbent. It's not good enough just to be a little bit above or on par. So as you're kind of building the company out and looking ahead to this market, what do you see as some of the biggest barriers and the biggest opportunities? And we can talk about like maybe the Canadian market specifically, but also more generally.
I mean, for sure, going back to the fundraising, a big barrier for all startups right now is fundraising. It's extremely
Yeah.
challenging. Historically, a lot of Canadian startups would rely on US investors. Having said that, like the Asian market is getting very active and European market is getting more active, but that remains a big challenge. I would say the second challenge still remains, we already talked about it, like marrying the source of CO2 in your production facility and your customer, like the offtake agreement. A, getting them as close together as possible, and B, removing as many barriers as you can, right? On a $10 million project, I'd rather not spend $3 million on carbon capture.
Yeah, yeah, right,
That's a big
right.
chunk of my cash flow. Building something that does not de-risk my technology.
Yeah, yeah.
De-risking my technology is scaling my technology and
Hmm.
having more sites running and having them running for longer periods so I get more data. Someone last year said it really well to me. In certain spaces, if you produce a new product, you really there's one direct path. In the energy space, there's so many interdependencies. And that is the
Okay.
challenge for startups. It is, I mean, I've spent my entire career in the energy space. I love it,
Yeah.
but you're never alone in that space.
Right, right.
If you need electricity, you need the utilities. If you need gas, you need the gas people. If you need CO2, someone has to give it to you.
And
That's,
it
yeah,
makes the space more challenging, but I think the flip side is there's the potential for great impact and leverage as well. Like it's really challenging to work within this network and web of systems, but if you're able to figure it out and kind of have that, it can be a really significant leverage point.
it's a bit of a double-edged sword, but I have to be honest, I think it makes the space, just more fun to be in because it's quite a
Mm,
collaborative space. It's not like you go to some other spaces where it's like really competitive cutthroat, but I think all of us startups in the clean tech space, we really wish each other success because if one person does well or if one person does not do well, it reflects positively, negatively on everyone else. And at the end, we need climate solutions. Yes, I want Secant Fuel to succeed, but what I want even more is that we solve the climate solution problem.
yeah,
And
yeah,
if someone
definitely.
else gets there faster and better, I'd be cheering them on all the way. So it's
Yeah.
yeah.
On the kind of partnerships front, do you see carbon capture startups as potential partners on projects, kind of teaming up to propose a project together, or are you more looking at like the industrials and kind of those existing customers?
No, definitely carbon capture companies
Yeah, okay.
are a strong partnership. Now they have a market segmentation, right? They will have a certain customer base that wants to do sequestration. That's fine. That's not where the partnership plays out. But they also have a large customer base where people have no choice but to do utilization because there are no sequestration options.
Yeah,
And
yeah.
in those cases, it is a perfect marriage because someone needs to take that CO2, and that's what historically has been the challenge with utilization technologies that you can only take a limited amount of CO2. And because right, it goes back to the double-edged sword of playing in the commodities market. Yes, it means you have to be hyper competitive for people to buy a product. But if you reach that threshold, you sell a lot of product. And if we sell a lot of product, so for every ton of product that we make, we roughly consume 2 tons of CO2.
Okay.
So we have the potential to consume gigatons of CO2.
Yeah, yeah. Okay.
And that, I think that's a big differentiator, that not every utilization, technology, or space has the ability to take large amounts of CO2.
And I guess that's probably the main upside in some cases for sequestration is like it can accept a
Yes.
huge volume.
Yes,
And so if
100%.
you're able to
Yep.
take, a comparatively large volume, that can differentiate you versus some of those other pathways. We're getting towards the end of our time. One thing I wanted to get your take on, so you mentioned at the outset, working with hard climate and this kind of like venture builder model. For other founders that are, building hard tech companies or watching this space, what did that approach give you that you maybe wouldn't have gotten from like a traditional incubator? What's that experience been like?
There's pros and cons to everything. I think
Yeah.
the con of the model is that clearly the venture studio takes a portion of equity. Not every founder is interested in it. There's founders who just say, it's my company, I want to run with it. There's nothing wrong with that. It's just a different approach. I think there's really two things that it gave. The model invests early capital, so it gives you about 18 to 24 months of runway where you don't have to worry about fundraising. And
Right.
fundraising takes a tremendous amount of time. It
Yeah.
easily takes 50% of a CEO's time. And that means you can't spend the 50% scaling up your business. So that's one. The other part is that it allowed us to pull a more experienced and diverse team together. So if you look at, for example, our executive team, yes, our CTO, Bruna, she's the co-inventor, co-founder of the technology. But she's really the only hardcore technical person. Our CFO has an entire career background in investment. My whole career, 20 plus years, has been project development and project building. And our COO's whole career has been around how do you de-risk and scale up planned and partnership development, et cetera. So we bring a really diverse and mature team to the forefront, and both customers and investors pick up on that very quickly. And
Mm.
I think it's just another way of de-risking and allows us to go faster.
It's a good point about the trade-offs, but having that those kind of upfront advantages is really cool. Any final ask that you have for folks listening?
That's a great question. I mean, the obvious ask is investors, but let's
Yeah.
get beyond that. I mean, let's get very focused on Canada. If you are an industrial player in Canada where you have CO2 emissions, you have an ambition to reduce those CO2 emissions, and you know that carbon capture is kind of a pathway forward. You might not be able to electrify your entire facilities and therefore have no CO2 emissions left. Let's connect. Even if it's early days, even though it might take us multiple years before we reach the scale of that facility, those relationships, they take a while to build up, but they're also extremely important because at the end, we always say, right, we need to build a product that solves the customer's problems. Without customer inputs, we might not build the right features for the right widget. So product development has to go hand in hand with customer intimacy. So talking to customers and just downloading what their problem points are, what for them would an ideal solution look like, even that conversation is extremely valuable.
And that's a great place to cap it off. So anyone listening, if you're in this space, give Jochem a shout. Yeah, Jochem, thanks so much for spending some time with us. This was a really, really interesting conversation. Appreciate it.
Thanks, Jess. It was fun. I really appreciate it.